good afternoon, depending on where you are. My name is Jakub. I'm here in Poland where we have 9 p.m. and I'm happy to talk about refactoring with you today. So typically on this show, which runs by the way every Wednesday 12 at noon Pacific time, we talk about code. We do live coding, but today, even though I'm going to talk about very code-specific thing, which is refactoring, by the way, also technology-agnostic refactoring, I won't be doing much live coding today. We are going to see many lines of code, but on the slides, I want to talk about something which is common, which I have seen at many different organizations, at many different teams, and with different clients I have privilege to work with. So probably you are familiar with what refactoring is about. Let's say that your code base doesn't look as shiny as you want it to look like. And so typically what you do, what teams do, they actually try to make it, well, more shiny. To polish that, to use patterns like extract method, extract object, put your class into a testing harness, put your method into a testing harness, extract interface, etc., etc. At some point, the code becomes, well, more shiny. It looks a little bit better at some point after more iterations, is as shiny as you want it to be, but even though it is shiny, it uses all of the latest and greatest tools from any technology you have and design patterns and so on and so forth. Even though you have it, the code doesn't change the fact that the underlying architecture or the model of your business problem is wrong, doesn't represent the real business needs, and every time you want to change something, every time you want to add a new functionality, it becomes very hard to do. Every change is, well, a breaking change. Every change requires to go into every single module that you have in your code base. So today we are not going to talk about this mechanical refactoring like extract method or any other that was already mentioned. But instead of that, we are going to talk about, well, so-called strategic refactoring. So refactoring of your architecture or refactoring of your model. We won't be touching techniques like extract interface and so on and so forth. So you might be familiar with bubble context, a term designed by Eric Evans, the father of domain-driven design, which is described as follows. Bubble context is an approach that involves creating a fresh context for a functionality, for a new functionality, or maybe refactored functionality that is shielded from the entanglements of the legacy world. And this is, at least in my experience, this is reality. Because even though we can refactor code, without refactoring the model or the architecture, we won't be satisfying our business needs. So let's talk about this global refactoring or strategic refactoring in the context of so-called big ball of mud architectures. Probably some of you are familiar with this term, big ball of mud architecture. People say that big ball of mud is an anti-pattern. I would say that every anti-pattern is a pattern in a specific context. So let's say the life cycle of your project would be 2 days or 2 weeks. Probably big ball of mud is the way to go. In big ball of mud, there are no constraints, no principles when it comes to code structure. Everything can talk to everything else. Every single module can touch every other module. Same applies to classes and so on and so forth. So people tend to say that big ball of mud is bad in the context of projects which have a longer life cycle, like strategic projects at our organizations. But the single fact that we say that something is bad, in my humble opinion, is not enough. The feeling of something being bad needs to be contextualized, like why is it bad? And we tend to justify our feelings with statements like There is no structure in the code base. The code feels sloppy or like duct tape style solution. But does it bring any more description? Like, these are again subjective feelings. What does it mean sloppy? What does it mean it has no structure? One developer can say it's sloppy because that method has more than 10 lines of code. Another one can say, well, 15 is fine, and so on and so forth. So we need to go deeper, deeper, and deeper to justify that with some kind of a metric, probably. And there is where coupling comes to our mind. What is coupling? Again, from my experience, when we say coupling, people have different things in mind. When I was first reintroduced to the concept of coupling when I was junior developer, I kind of understood what is it about, and that I shouldn't be doing that in my code base, but I haven't seen the long-term implications because, well, I was a junior developer. What did I know? Months after that, I understood that there are different kinds of couplings, like there is logical coupling, spatial coupling, there is temporal coupling, there is platform coupling. We can be coupled to any other thing in our architecture, in our code base. And when most of the developers say our solution is tightly coupled, they refer to the consequence, which looks like follows. Every time I need to change module A, module B, C, D, E, F, G, they need to be changed as well, even though they have nothing to do business-wise to the module A, with the module A, which means business-wise they are not related, but everything is related in code. So single change and single module, business module, is propagated to many technical modules, and all of those need to be changed. At some point, the solution, the code base, becomes hard to understand, hard to maintain, and, well, hard to deliver value. This is mainly because of this logical structural coupling. It's hard to maintain because every fix or new feature breaks unrelated part of your system, right? Because information is shared across distant elements of your system. It goes down to questions like how productive a new developer is in such a code base. Does it take 6 months for them to deliver a new feature or to even understand the code base? How long does it take to deliver a feature by not a freshman? How hard it is to estimate that when we don't know what might be broken. That's hard to do, right? That's why we are bad at estimates as developers and architects and as IT per se. So then there is this magical world. We tend to say, well, it's time to refactor. I need to refactor this solution because it becomes hard to understand unless we do that. Well, I guess that might be a good idea, but I would like to share a story with you. The single fact that the code looks bad might not be the best justification of refactoring. So the story goes as follows. When I was junior developer again, I read Clean Code and many other books related to the topic of good design practices, refactoring, and so on and so forth. And part of the system I was currently working on didn't follow any of the great guidance I learned from those books. I'm talking about, naming convention, good rules like don't repeat yourself, keep it simple, grasp, solid, Yagni, etc. So I decided to fix that as an engineer. And it took me 3 months because my manager allowed me to do so. It took me 3 months. And I felt really lucky at the very end because I didn't get any merge conflict within this period of 3 months. Turned out at the very end that I wasn't just lucky. I didn't get any merge conflicts because, well, nobody cared about this module. It was module related to communication with people, with customers via text messages, push notifications, or even Postmail. I don't really remember, to be fair. But what I remember is that there were no new feature requests, no bug requests past 2 years. The code wasn't good, but it did its job. Nobody needed to understand that code because, well, there were no feature requests, no bug requests, and so on and so forth. So I learned something. We need to justify refactoring with business value being lost. May it be money, it may be business opportunity, or just risk. Explanation like we need to do clean code might not be enough because we don't refactor for the sake of refactoring. We refactor for the sake of having a return from that investment. Because our job at the end of the day is bringing value, not just satisfying our aesthetic needs. I know it's tempting to change the code which looks bad, and don't get me wrong, if I see such a code and it takes like 3 minutes, then yes, because the investment is really small. But if the investment is really, really big, time-wise or money-wise or resource-wise, in that term, I would say, well, we need to justify that with some return of that investment. Like, let's wait for a while. Maybe this code is stable. Maybe nobody uses that, which means nobody needs to read that. Maybe last time it changed, it was 3 years ago. Things like that might be helpful. Well, so that small and short story shows that maybe we need to find better drivers to start refactoring. But what is refactoring anyways? Like, how would you describe that? Is it a rewrite? Is it a feature? Is it making our code following solid, Yagni, and all of those great rules? Is it trashing the old system and replacing with a new one written from scratch? What does it really mean? So probably the more people we talk to, the more definitions we have. I like the definition provided by Michael C. Feathers in his great book, Working Effectively with Legacy Code. And he says that code refactoring is the process of restructuring the existing computer code, so changing the factoring without changing its observable behavior. And I cannot stress that enough. Without changing its observable behavior. So we change the structure without changing the, well, let's say, functionality. When we don't change functionality, it's hard to talk about that with people who are not, who don't have technology background, because probably nobody is going to pay for that. Well, how to convince business people to do that? Probably many of you have failed trying to convince business people to do refactoring. I have failed too. I would like to share a couple of tricks learned from the battlefield, at the battlefield. First thing first, don't say refactoring, because when we developers, when we say refactoring, we hear refactoring, so probably changing the structure so that it's more readable and so on. But when we say refactoring to business people, they might hear something different, like fun, procrastination, or CV-driven development. I'm not going to pay for your new shiny tools. I want business value, whatever that means, right? So don't use that word. Instead, try to create a common understanding. You can do that in many ways. One of the ways to create common understanding is to understand the process and try to point the hotspots in that process, in the business process, which is described with business language. And the time lapse you are seeing right now comes from an event storming session, which basically helps you to understand the business process, because you talk with business people using business language. And you can use sticky notes like orange sticky notes for domain events and pink notes for hotspots. And after this kind of session, you probably have the most problematic place in the entire organization. It might be code related. In that case, people without technology background, they will see the return of that investment. Well, this problem will be gone. But that's not enough. It's also good to use measurable data. What I mean by that? What does it really mean? OMG, it takes ages. So business people, they love numbers, right? They love hard data. They love Microsoft Excel. So what does it mean? Again, it takes ages. How much does it really take? Let's say we have to justify refactoring of some read model in our database because our web page for a call center agent opens up for 10 seconds. And let's say that those agents, they have to do it 200 times per day. That means if we have one agent, we lose 2000 seconds per day, which is around 35 minutes. Let's say we have 10 agents, which is, well, not, which is likely to happen, I would say. So in total, they lose 6 hours a day. If we now multiply that by their salary, it means that after fixing that, they can hire one more agent for free, almost. So that's the kind of hard data that really gets to people. And you know you did a good job justifying refactoring properly when those people, business people, when they get mad. And I really mean that, because after this kind of explanation, their reaction might be like, what the hell? Why haven't you told me that before? Well, I tried to do that, but I have used different language. I was talking about read models, new version of ORM, and so on and so forth. So common understanding, measurable data, so that we are on the same page. These are good techniques. If that's not enough, maybe, just maybe, it might have been that in the past, business people, they agreed on some refactoring, and after this kind of, refactoring, the system started to behave worse than it used to behave before that session. In this case, tell them that this time is going to be different, because we are going to use magic, where magic equals good engineering practices, and I can give you, dear business, a new shiny button, and you can just click that if something goes wrong, and we'll just revert all of the changes. So the reaction might be, well, that's interesting. So you're saying it's totally safe, and I can easily revert that without having to call you? Yes, you can do that, and you don't even require any new shiny tools to do that, by the way. So we know what refactoring is about. We know when to talk, how to talk with business people about refactoring, and when to start thinking about refactoring. But let's say that the biggest pain point, or one of the biggest pain points, is how to do that. So now let's focus on the nitty-gritty details of actually how we can apply this way of thinking in the legacy system. So let's say we have the current state represented by the brown emoji, and we have the desired state represented by the unicorn emoji. And well, according to the definition of refactoring, we need to keep the desired state. In the desired state, we need to keep the observable behaviors of the, well, current state. But the factoring of our program should be probably better. So how to move from the left to right, and how to do that without tests? Because, well, have you ever seen a legacy system which is nicely tested? I think it's against definition of legacy system, so probably there is no such a thing. So good news is that those observable behaviors can be expressed as automated test scenarios. The bad news is that it's going to take time to introduce. Also, there is one thing that needs to be clarified when we talk about tests in the context of legacy system. So in a nicely structured code base, it's really easy to spot units which are easy to test, because we can take them out, we can talk to those units via API. By the way, this API represents the observable behavior which this API can do, and everything in the inside of that unit is an implementation detail, right? That's easy. But in big ball of mud, well, there is it's hard to find clear units, right? Probably also there are no tests, and it's hard to create them. In big ball of mud architecture, when you reach for the banana, you get the entire gorilla. You want to test module A, all of a sudden you need to also stub or mock module B, C, D, F, G, and so on and so forth. It's really hard to do. So in this kind of situation, what you need to do is to try to find a higher level unit from which you can actually treat everything which is down there behind this unit as implementation detail. It's not going to be a nicely structured set of classes. It will be a huge number of classes probably. In some legacy systems, this higher level unit is even the surface of the system, which means you can only test on the end-to-end level. But if it was easy to add unit tests, it wouldn't have been a big ball of mud in the first place, right? Which means that when you write those tests, probably you ain't gonna have this nicely structured, nicely shaped testing pyramid when you have in a fairly complex business application with complex business logic. You have huge number of unit tests, some integration tests, and then just a few end-to-end tests to cover the happy path scenarios. Well, it cannot be done. Probably we'll have something like this, just some unit tests, more integration tests, and huge number of end-to-end tests, which are slow, yes, but that's our transition period. Probably we can fix that later on. But this is the answer to the question how to test, but what to test, how to find the scenarios to test. So if you talk to business people about those observable behaviors, for instance, during the event storming session or any other, or by applying any other techniques that can help you with gathering the business requirements, you will find them, and what you need to do is to map the business intentions like commands and queries that can be run against the system to the technical components that handle them. If you do that, you can write tests as follows. Let's say we are fixing or refactoring library, like a library in the good old-fashioned days when we could go and lend a book. So we have the observable behaviors that you can see. One of them is a patron who wants to place a book on hold, and if that is successful, at some point when we take a look, hey, what are my currently reserved books, you will see that book. These are two observable behaviors, but the test doesn't speak any technical details. Of course, underneath that methods, like patron wants to hold the book and place on hold books by patron, you will call your technical API. This is this mapping between business intention and technical component which handles that business intention. So that's one way of applying, of finding business scenarios, talking to business people, talking to users, and so on and so forth. When you don't have time for that, or they don't have time for you, or you want a different technique, you can also try to reverse engineer the rules from the tests. So you can actually try to write some tests and run them and see how the system behaves. Like in the database, maybe there's a book which is domain-driven design. You have two patrons. In the legacy system, they are represented by book holder entity, John and Amy, and you run this code. Patron wants to hold the book. Domain-driven design. It's John. You run the code and you get an exception. Why? You have no idea, but this is how the system behaves so far. So this is an observable behavior. You want to keep that. So you assert it's going to happen in the subsequent invocation of the test too. You do the same with Amy, and in this case, you got a success. Why? Again, you might have some feelings about it, like why, but you are not sure. But you are sure that this is an observable behavior that you want to keep. So you assert. And you get some heuristics about business rules. It might be something special about John. Might be something special about Amy. Maybe something about DDD book. Maybe there is a rule that you can place on hold top only 5 books maximum. I don't know. You have concrete questions that you can ask to someone, like more experienced developers or maybe business people, which will spend less time answering those questions than they would have spent if you talked about any other business scenario, which is not that precisely asked. And how to make the transition when you have those tests, like from the left to right. So I have experienced at least 2 different ways of doing that. Option 1, you climb step by step. So you gradually apply some kind of transformations to the brownfield solution. At some point of time, you have it migrated to a better solution. This works well when you see the actual path from left to right. Option 2 is a little bit different, so you might want to see that the problem that you are trying to solve, it's really simple, but the solution that is trying to solve that problem is really complex. And it's hard to start from this complex thing to simplify it to something simple, so we write it from scratch and you have two models side by side. I call it blue-green refactoring, which probably correlates with blue-green deployment, which is a term you are probably familiar with. So let's start with step-by-step refactoring. The problem, there are some benefits and problems. The benefit is that there is only one model to maintain at any given point of time. So it's already connected to the outside of the application. It works well. Maybe not well, but it works. The problem is that after some weeks, you might want to see that there is dead end. I don't know what to do. Or maybe you made a mistake 3 weeks ago, and it's a crucial place in your system, and the bug started to occur 3 weeks after you did that bug. So it's hard to roll back, especially if you did some data migration. Also, you need to dig in this mud and try to simplify this complex model into something simple. It might not be that easy, right? So what I have experienced is that people abandon this way of step-by-step refactoring halfway through. So what's between this mud and the unicorn? I don't know, we can describe it as this. It takes skills, determination, it takes patience to actually move from something which is so far away from the ideal solution that you want to have in your code base. If the ideal solution is simple because you understood that the problem is simple, or maybe the problem is complex but you have simple model to represent that complex problem, maybe it's easier to write it just side by side. And in this case, it's easy to roll back because you haven't changed anything. Your change is additive. You might want to say it's backwards compatible. And also it feels a little bit like doing greenfield, right? But the problem is that if it takes 3 months, there will be probably new business features related to that model, and they will need to be represented and implemented in both places. When it comes to structure of your model, if it's Java, you can use a different package or different model, depending on your choice. But the problem is, if you are done, the problem, the solved problem lies in isolation. Nobody talks to the unicorn because every single model that used to talk to the old model still talks to the old model. You need to connect the new model to the observable behaviors that were invoked previously by the clients of that not so nicely structured model. So if you take a look at this red dot, it represents the point where we want to make the decision, and behind that point, well, everything that goes behind that point, it's an implementation detail from the point of view of anyone who's calling the red dot. So we have two different implementation details. They actually do the same, but in a different way. The unicorn is easier to maintain, more readable, and simpler. But from the point of view of the client, it doesn't really matter, unless you did some mistake in one of the models, unless they are not synchronized properly. So how to find those places where those red dots should be injected to? So probably in a legacy system, it might be even a controller. You have queries, you have commands. Green nodes, they represent queries, like give me books which are currently collected by my account in your library, or place that book on hold. It's a command, a blue node. So when it comes to query, it's a little bit easier because it might be that your controller has like 100 lines of code. What you want to do at the very end, you want to call the new model, or maybe you want to inject the red dot and put the old model result through that red dot. Why? Because if we call now this red dot anti-corruption layer, it has also some responsibilities, like it separates our clients from the knowledge that, well, underneath we have two different models and we can actually change which one we are now invoking via, for instance, feature flags, like dynamic if statements that can be changed from true to false and vice versa, with intuitive user interface that you can even give business people access to. On the big picture, it looks like this. You query, you inject the red dot, and you call or either the old model or maybe the new model. You might want to have also two different data models in the database, one of which is probably more performant and simpler. This is what makes it safe, to run two different models at the same time, to run two designs at the same time in parallel, and you can switch, right? With this feature flag, for instance, which is the magic button we've been talking to. When it comes to a command, it's a little bit different because command, it needs to change state in two different places. When you place a book on hold, you want to represent that in the old model and also in the new model. So you inject the red dot again at the very end of the place where you found those observable behavior, place book on hold, and it's mapping to the technical component. In this case, is a controller again. And you do parallel operations for commands. So you change both old model and new model. If your database supports ACID transactions, probably these are your friend, but be aware, because if you did some mistake in the unicorn, it will affect the old model, which means the system cannot behave like it used to behave before refactoring. Also, some people might want to say that it is slower for a while right now. Yes, it will be slower for a while. If you want to make it faster, do it in a different transaction, but in this case, you lose the immediate consistency of two different models. So you have your choice. So what we need to do, we need to assess the architectural drivers. What's more important to me, consistency or performance for the time of refactoring, and then choose the best solution which is out there. When it comes to the package structure and the red dot, we call it ACL, anti-corruption layer. It might be a different package, different module. Again, the same story as we described with new model package. On the big picture, it looks like this. You have dependencies between packages, and the old model, like the entire code base, instead of talking to the landing model of books, which is the old one, it now talks to the red dot. And from the point of red dot, now we have choice. So everything that talks to the red dot doesn't really know. And they shouldn't know that underneath there are two different models. So this kind of refactoring gives you not only safety, but also actually can tweak your new model with the insights from the old model from running production. You can reconcile at the point of the ACL old model with new model. You can run those two even though you are still using the old one, but in the background you compare whether they behave correctly, whether the new model actually works the same as the old one. Reconciliation might be very simple. You just compare. If there is a difference between the old one and the new one, you might want to react, and the reaction might be whatever you want. You can be very creative with that. Maybe it's a strategic place in your code base, so you automatically disable the flag to use the old model, and it feels like self-healing system. You might want to send an email to some developer or some team, whatever you want. With this way of refactoring, you can incrementally deliver value. You can go to production, switch toggle to the old model, of course, and reconcile. Even though you haven't finished, you just migrated one simple endpoint. You gather feedback. You switch toggle to the new model when you feel that's the point, that's the time. And you wait for the call. If it fails, you just send it back again to the old model, and so on and so forth. And then at some point you add the new model to the new view or new feature in your code base. You have choice. You might want to start with a partial feature for one of your strategic clients. Maybe then at some point you have entire feature for one client. At some point the feature works for all new clients, and at the end of the day you do data migration and it works for the old clients too. So incrementally you can deliver value, and you can build trust between IT people and business people. And even if you fail at some point, they will give you more time because they have seen your results each week. When it comes to technical details and more tests, for instance, because we need to go back to test and probably we need to reshape our testing pyramid, you can write automated verification of two models if you want. So you invoke an endpoint, you change the toggle to use the new model, you invoke the endpoint again, and you compare the result. It should be the same. You can do data migration and test it too. And we spoke about this testing pyramid, which is a little bit problematic for us right now, because we have huge amount of business logic which should be unit tested, but it is tested at the level of the unicorn in the new model. So probably you have duplication when it comes to test scenarios, which means you can reshape it back to what it should look like in an application which has huge amount of business logic and doesn't have that much presentation logic. At some point you are sure that the new model behaves correctly. What you can do is you can delete the red dot, the old landing model, and now what used to talk to the old model talks to the new landing model, and it was safe. And this is how the bubble, the new fresh context, can be introduced into your legacy system. Some lesson learned at the very end. Go to production and reconcile very quickly instead of doing this big bang release after 6 months. So after first view, after first feature you migrated, just do it and go to production, of course without using the new model, but let's start gathering feedback in the background. Also, it is much easier if you refactor when you just query data. When you just query data, it's easier because it's hard to put your database into inconsistent state when you, don't change state because you just query data. If you want to see more about this, I have a GitHub account, and you can find there a project which is called Big Ball of Math, and every step in Git is described as a Git tag. So you can check out like Git introduce ACL, Git checkout introduce new model, Git checkout introduce automated verification of two models, etc., etc., with a simple scenario and simple business application which represents this library that we have been talking about so far. That's it. Remember, we have this show every Wednesday, 12 Pacific time. See you next Wednesday. Have a great day or good night, depending on where you are. Bye-bye.